Volume. So today we are going to talk about properties of powers. Okay, and a property of something is what it's about. Like, for example, you have brown eyes. So one of your properties is that you have brown eyes. Another property is you have brown hair. There are things that are about you. So first, we're going to start with the product of powers. Product of powers. Now, product is the answer in a multiplication problem. So for example, if I gave you say I gave you x to the power of m times x to the power of n. What would happen is this is a multiplication problem. The word product indicated that it's a multiplication problem. But the powers are the little numbers that sit on the shoulder of the base number. And when you are multiplying, the powers add. So x to the m times x to the n is x to the m plus n. X to the m plus n, because the powers add. That's clear, plus. Okay, now I like to tell my students that the powers are like bossy little numbers, and they sit on the shoulder of the base numbers and they whisper in their ear. And so they say, what type of problem is this? And obviously it's a multiplication problem. So in a multiplication problem, the powers never cooperate. When we start talking about exponents, you're going to see that the exponents always cooperate. I mean, not the exponents, the coefficients cooperate, but the exponents don't. If you're doing multiplication, the powers say, we don't want to multiply. See, multiplication looks like this, right? And they say, we don't want to multiply, we want to add. So they take this and they turn it around and they do addition. So in other words, if I gave you a to the b times a to the r, that would equal a to the b plus r, because the exponents will not multiply. They will not do what you're doing. If you're multiplying, the exponents add. They say, we don't want to multiply, we want to add. So if I gave you 2 to the third power times 2 to the fourth power, say, what kind of problem is this? It's a multiplication problem. We don't want to multiply, we want to add, because they're bossy little numbers that sits on the shoulder of the base number and talks in its ear. So this will be 2 to the 3 plus 4, which is equal to 2 to the 7th power. So to prove that this problem right here is correct using the method, 2 to the third is 8, because 2 times 2 times 2 is 8, and 2 to the fourth is 16, because 2 times 2 times 2 times 2 is 16. So 8 times 16 should be the same as 2 to the 7th. So what is 8 times 16? 6 times 8 is 48. 1 times 8 is 8, plus 4 makes 12, 128. And 2 to the 7th, if you multiply that out, you will get 128. So you can see that this method is correct because it gives you the correct answer. Do you understand? Does that make sense? Okay, so this is called product of power because, again, the word product means multiplication, the answer in a multiplication problem, we're talking about power. So product of power. So when the problem is multiplication, the little spoiled powers that sit on the shoulder of the base number say, we don't want to multiply, we want to add. And I'm going to tell you a little story. This reminds me, when I was in grades 2 and 3, it was a little girl in my room. Her name was Beverly, and she was a midget. You know what a midget is? A very short person. But she was beautiful. She was the prettiest girl you ever want to see. She had beautiful brown, golden brown skin and beautiful long golden hair like yours, except hers was very wavy, but it was very pretty. And she won a beauty contest. She was so beautiful. So she got spoiled. So at lunchtime, the other girls, second grade girls who were so much bigger than her, and the fourth and fifth grade girls and the big girls would sit her on their shoulder. That's how small she was, and walk around the playground with her. And she would just boss people around and say mean things. So if she was a power, and they say, what kind of problem is this? What kind of problem is it? Good, it's a multiplication problem. She would say, we don't want to multiply, we want to add. So when the problem is multiplication, the powers will add. Okay, and that's the product of powers. Now, we're going to talk about, and I'm going to use Beverly in all my problems, because Beverly was, I thought she was the prettiest, nicest girl, but when she became so bossy, I kind of didn't like her as much because she was too bossy and she never wanted to do what was being done. She always wanted to run the show. So the next thing we're going to talk about is quotient of powers. Quotient, Quotient, quotient of powers. Quotient is talking about division. If you say, what is the quotient, you're talking about a division problem. So for example, if I gave you x to the m divided by x to the n, it is a division problem. So what kind of problem is it? It is a division problem. So this also reminds me of the little girl who was so spoiled. Because it's a division problem, you would say, what type of problem is it? It's a division problem. And she would say, don't divide, subtract. So what she would do is take the two dots and erase them and do subtraction. So when you have division, the spoiled little power would erase the two dots and say, I don't want to divide, I want to subtract. So when it's division, the problem actually subtracts. So the way you do this is you start with the numerator minus, take away the denominator. So x to the m divided by x to the n is a division problem, but the powers are obstinate. They do what they want to do. So that would be x to the m minus n. Because the powers don't do what the problem is doing. The problem is dividing, the powers, I don't want to divide, I want to subtract. So base those and do subtract. So let's prove that that is correct. So suppose we had x to the third. Okay, as soon as I finish this part, take away or divided by x to the second. So that would be x to the 3 minus 2, which is equal to x to the 1. Okay?
So it's, I mean, I don't mind.
Okay, let me just finish this part here and then you can have it, Mr. B.
Okay.
So x to the 3 divided by x to the 2 is x to the 3 minus 2, which is equal to x to the 1. Now let's try this out. Suppose x was 2. Okay, let's do the same problem. 1 minute, Mr. B, because I know you're excited.
That's fine.
So this will be 2 to the third divided by 2 to the second, which is really equal to 8 divided by 4, which is equal to 2. Okay, but if you did it the other way, 2 to the first power is equal to 2. So it proves that this method is correct. Okay, because the powers say we don't want to divide, we want to subtract. So when the problem is a division problem, we didn't get to the coefficients yet.
Yeah.
The problem is a division problem. The powers say, I don't want to do division. It's a division problem. I want to do subtraction. So the powers subtract. So now we have our mathematician
No,
here.
no, I just want to pick up a little thing, right?
Go ahead,
So-
Mr. B.
For you to, if it's division, the base has to be the same. It has to be
Oh.
X and X.
That is a very important point. The bases have to be the same. If the bases are not the same,
You cannot-
we cannot do this. We're only talking about, like, the base is the big number. Like, if you have a lamp, you have a shade, and then you have a base that it sits on. And this is the base. The base is usually at the bottom of something. So the base is the big number, and then the shade is up here. So the bases are X's, and the powers are up there. But if the bases are not the same, as Mr. B, the mathematician said, there's nothing to talk about because it won't work.
And then one more thing I want to point out, right? When you're doing the subtractions, right? So you always subtract the smallest from the highest, right? Let's say the highest was at the bottom. You still have to do it because you still have to do, the subtraction down here.
Mhm, mhm,
You see what I'm saying?
mhm.
That way will be your 1 over whatever is that one is. So
Exactly.
this is a little thing, you wanna
Yes,
point
and
out.
those are good points.
Yeah,
And I'm particularly happy that you emphasize the fact that the bases have to be the same. And all the problems we're talking about
Yeah.
today, the bases will be the same. If the bases are not the same, then I'm not talking about the right
yeah,
thing.
yeah. Like
Okay.
two, if the base is 2, you can do it with 2. If you have another base with 4, 4 and 4, whatever, just.
But if the big number,
um,
like the base of the lamp, is not the same, then there's no need to
Is
talk
that
about
what's
it.
holding the exponent, that's the base, so.
Thank you, Mr. B.
That's okay, just a little thing.
And ladies and gentlemen,
We do it together, right?
right,
Yeah.
Mr. B loves math and he will always help us with the very important things. So now we know 2 things. We know about product of powers and quotient of powers. Let's talk about a power of a power. A power of a power, and as Mr. B pointed out, we're always talking about bases that are the same. Bases not the same, don't talk. Okay, so a power of a power is kind of like if you have a number in parentheses and it has a power on it, like x to the m. And then you take that power and you put it in parentheses. When you put something in parentheses, the parenthesis says, I am in charge of everything inside. Okay, so this is a number that has its own power, but now the parentheses indicates that we're taking a power of that power. So x to the m, and then let's take that whole thing to the n power. Now that is very powerful because we're dealing with 2 powers here, a power of a power. So I like to say a power of a power is a very powerful thing. So you multiply the power because it's so powerful. So it's x to the m times n. Okay, now let's prove that that's right. Suppose x, I'm using small numbers to make it clear to you. So suppose x was 2 and m was 3 and n was 4. Oh no, let's make n 2 to make life easier. So first, in math, we always do what's in the parentheses first. It's kind of like in your house. You clean your house inside out. You probably don't go outside and start cleaning out in front of the house until you clean the inside of the house. So we work our way inside out. So 2 to the 3rd is 8. We did the inside, and now we square it. 8 squared is equal to 64. So this is 2 to the 3rd squared would be 2 to the 3 times 2, which is 6. And 2 to the 6 is also equal to 64 because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6 is also equal to 64. Okay? So now we know a power of a power is a very powerful thing. We multiply the powers. So what's happening here is we're learning a lot of different things. And we'll be working on this lesson for a few days, but it'll just make sense. We'll do worksheets on each one. So this one is a power of a power. I'm making it right along. I'm on the last sheet. So I guess that's the last one I'll do today. And this one is called a product of a power. Product, P-R-O-D-U-C-T, product of a power. Oh, no, it's called power of a product, not product of a power. It's called, sorry about that, power of a product. Okay, so we know we're talking about powers, but we also know we're talking about multiplication. Power of a product looks like this. A product is something that's multiplied together. So say I multiply X times Y, that's a product. When we multiply two variables like X and Y, we don't need the times sign in between because it's understood. Nothing between them means multiply. So there's our product. And when we take a power of it, we can raise it to the power of M. And the way that works is the M again is like that spoiled little girl. And she says, I go for both of the numbers inside the parentheses. You're under my power. But those two numbers inside the parentheses are under or inside of the power of the M. So when we have a power of a product, that means that the power goes for both of them. Like this is Ileana and this is Daisy. And this M is Mr. B. And Ileana and Daisy are both under the power of Mr. B because he says, both of you girls are wonderful. I want to help you both to learn math. So both of you are under my mathematical power. So the way that would work is we get X to the M times Y to the M. Okay. So this is called a power of a product. Now let's prove that it's right. Let's say if X was equal to 2 and Y was equal to 3 and M was equal to 2. I'm only using small numbers. Okay, so 2 times 3 would be 6. And 6 squared would be 36. So this is the same as 2 to the second times 3 to the second. 2 to the second will be 4, and 3 to the second will be 9. So 4 times 9 is also 36. So you can see that the power of a product works. It's again, it's like Daisy and Eliana, and then there's Mr. B, and he's the math guy, and he says, the two of you are inside of my power, so I'm going to help both of you with your math. So first he goes and helps Daisy, and then Eliana. So XY quantity to the value of M is equal to X to the M times Y to the M, because both of you get his attention. And you know he does that. He shoots around the room and he helps this one and then he go helps that one. Doesn't discriminate. Okay, so X, Y quantity to the M is equal to X to the M times Y to the M. And the proof is in the pudding. 2 times 3 squared is 6 squared, which is 36. And 2 squared, given the power to the first one, times 3 squared, given the power to the second one, gives me 4 times 9, which is 36. Okay, so we have learned 1, 2, 3, 4 different things. So what we're going to do is review the 4 that we learned. And I'll ask you questions and you can answer them. The first thing we learned was about product of a power. And that was when we had 2 products multiplying together. X to the m times x to the n. And as Mr. B said, the bases have to be the same. In every single one of the problems we're doing about laws of exponents or properties of exponents, the bases are the same. So when it's multiplication, the powers say, we don't want to multiply, we want to add. And I'm going to write this again. It's the same thing, but since it's not clear, this is equal to x to the m plus n. Yeah? And there we have the truth of it. So, Eliana, when the numbers are multiplying, and that's a product, what do the powers do? Plus, yes, add, plus, add, very good. Now, this one was quotient of powers. Don't try to do the IXL yet, because we're not there. So you get that off. You can do some catch up on something else if you want. Now, this one is quotient. When you hear the word quotient, you know we're talking division, quotient. And if you see a fraction is a division problem. So this is a division problem. Again, the bases are the same, but the powers are different. So when you are dividing, what do the powers say? We don't want to divide, we want to minus or subtract, say subtract. Okay, so x to the m divided by x to the n is equal to x to the m minus x to the n. So if we gave m and m values, we would have x to the third divided by x squared, which would be x to the 3 minus 1, which would be x to the 1. If we gave this numbers, if we gave x the value of 2, m the value of 3, and n the value of 2, we would have x to the third, which is 8, divided by 4, which is 2. And again, this led us to x to the 1, which is 2. So it proves that we are correct. And this one was a power of a power. And that's like, there's a power, but then the number with the power taken to a higher power. So x to the m taken to the power of n, it's a very powerful thing. You multiply the powers. So that's x to the m times n. So if we give value of 2 to x and 3 to m and 2 to n, we would have 2 to the third taken to the power of 2, which is 2 to the 3 times 2, which is 2 to the 6, which is 64. And to prove that that's correctly, if we did it this way, 2 to the third would be 8, and 8 squared would be 64. So there we have it. And that is it for the first 4 properties of exponents. Thank you. I hope I was recording.